So for Tuesday's skills practice, we're going to do 8 problems. I'm going to do the first 4 with you pretty step by step, but then I want to see how well you can do the last 4 on your own. So we'll try to get you a little more independent by the end of the class period today. So looking at number 1, we have a situation involving Northern Kentucky University. This says in-state tuition at NKU is about $12,000, and it's increasing by a factor of 1.06 each year. So the first thing I'm going to do is pick out some important words from this problem. Part A asks me to figure out whether this is growth or decay. So I'm going to look for a word in the problem that might indicate growth or decay. And the word that I'm noticing that will help me figure that out is this right here. Tuition is increasing. Increasing indicates growth. So for part A, you're really just looking for that key word in the problem that tells you whether your amounts are going up or going down. This is obviously going up because it's increasing, so we're dealing with growth. So moving on to part B, since this is a growth model, we know we're going to be using something in the form y equals A times the quantity 1 plus R to the T. That's what growth tells us, is that we're going to be using a plus there. So we need to read our problem and look for an A and a rate. So our A value is our starting amount. Well, the starting tuition, or the tuition at the start of this problem, is $12,000. So we would write y equals 12,000. And now we're looking for this 1 plus R. So we're looking for a rate. But in our problem, they don't give us a rate. Remember, a rate is usually a percentage, or at least a fraction of some kind. Here, they're giving us specifically a factor. If they give you a factor, you do not have to go through the steps of finding your base. The factor itself is the base. So this entire base right here just gets replaced with 1.06. So we'll write in parentheses 1.06 to the T. So the factor problems are the easier problems. This is our answer to part B right here. Y equals 12,000 times 1.06 to the T power. For part C, they're just asking us to plug something in. They want to know what the tuition would be expected to be in 4 years' time. So in 4 years means we're going to be plugging 4 in for T. So we'll take our equation that we came up with in part B, y equals 12,000 times 1.06 to the T power, but instead of T, we're plugging in 4 now. And this is a job for a calculator. So grab the calculator that's on your desk and be careful as you type this in. You have to type it in exactly the way it appears on your page. So you'll type in 12000, 12,000, parentheses, 1.06, close parentheses, exponent button, 4, and hit enter. When I type all of that in, I get $15,150. I'm rounding this a little bit, just rounding it up to the nearest dollar. On problems like these, when you're doing a quiz or a test, the answer choices, they'll be multiple choice, right? So you'll be able to look at the list and find the number that matches this the most closely. So don't worry too much about how many decimal places do I need to round it to. Because if one of the answer choices on the quiz was, 149.72, you'd be able to find that on the list. Okay, so as we're doing these problems together, don't worry about being super exact, because as you know, you'll be answering multiple choice questions when it comes to quiz day. All right, so any questions about that one? Do we understand the process? That was a bit of a tricky one to start off with, because we started off with a problem that involves a factor, which is not our typical case. Most of our problems won't start us with a factor, they'll start us with a rate. So let's move on to an example where that's the case. Number 2 says, in the year 2015, you buy a car for $18,000, but it is depreciating at a rate of 12% per year. Part A asks us to identify whether this is growth or decay. So we're looking for a key word that will help us figure out if we are going up or going down. And that key word is a word that I mentioned yesterday in our guided notes, depreciating. This is an accounting term that means that something is losing value. It's depreciating in value, or it's losing value. So that would be decay. Easy to remember because they both start with DE. All right, part B asks us to write an exponential function to represent the situation. We need part A in order to do this, though. We know that this is decay, so that means we're going to be using the y equals a times 1 minus r to the t. So you first have to identify that this is decay before you can figure out which formula to use. And now we need to figure out what to plug in for a and r. A is our starting amount, or our starting value, and r is our rate. So reading the problem back, I see that the car started out at $18,000, so that's what we're going to put in for A. And the rate is 12% per year. We won't put percentages into our algebra problem, though. We have to first convert 12% into a decimal number. So we take the decimal on the 12 and we shift it to the left 2 places. So our decimal number that represents 12% is 0.12, 0.12. So remember, you always have to convert your rate into a decimal before you plug it into your equation. And we're going to do one more step here. What we've written so far is correct. And if you see this option on a multiple choice test, you can select it. But sometimes they'll simplify your answers for you a little bit, so we might have to do the same to find which answer choice is correct on a list of a few options. So I'm going to take the 1 minus 0.12 and actually calculate that. 1 minus 0.12 is 0.88. So we could write this as 0.88 to the t power. Just simplify basically the stuff that's in parentheses. And after we've done that, I want to take just a moment to appreciate what has happened. 1 minus 0.12, that's like taking 100% minus 12%. So we start with 100%, we're taking away 12%. If you take 100% minus 12%, you get 88%, which is what this is, our base, 88%. 0.88 is 88% if you move your decimal back over. So basically what we're doing is we're figuring out what's left after we take away our decaying rate. And that's where you get your formula. All right, so let's move on to part C. Part C requires us to take our formula, y equals 18,000 times 0.88 to the t, but instead of t, we're going to be plugging in a number. They want us to figure out how much the car will sell for in the year 2021. So am I just going to plug 2021 in for t? Holy moly, heck no, that's not how this works. Remember that t, time, represents how much time has passed. So if this problem started in 2015, and the problem's asking me to analyze the answer in 2021, how much time passed between those 2 years? 6 years. 6 years has passed. So in for t, we're going to plug the number 6. Grab your calculator, plug that in. You should have gotten about $8,359. If you got something different, you're using the calculator wrong, and we need to figure out what the problem is. So compare your answer to mine and make sure we got the same thing. Does anybody have any questions about how we should be plugging these into our calculator? All right, let's move on to the next problem then. In problem 3, we've got an algebra textbook. When the algebra textbook was originally published in the year 2019, its value was $158. Its sale price decreases by about 7% per year. So part A, which is asking us about whether this is growth or decay, requires us to identify the key word in this problem that tells us whether we're going up or going down. And that key word is decreases. The sale price is decreasing, which means we are in a decay model. Once we know that it's decay in part A, we know for part B, we're going to be using a model where we take A times 1 minus rate to the t power. So now all that's left for part B is we have to figure out what A and R are equal to. A is our starting amount or our starting value, which we can pretty quickly identify in the problem as $158. Then in the parentheses, we're going to take 1 minus the rate. Our rate is 7%, but remember you have to convert that into a decimal number. So if I have the number 7 and I shift its decimal place over 2 spaces, we have to fill this kind of empty gap in with a 0. You get 0.07 or 0.07 to the t power. So this is an answer. This is a correct answer, and this might be one of your answer choices if you were doing multiple choice. Or maybe the answer choices are a little more simplified. So let's simplify this just to take a look at it. If we simplify the 1 minus 0.07, inside those parentheses, you end up with 0.93. And you can use your calculator to do that. Or some people can do it in their head. So just again, to point out exactly what happened here, if you take 1 minus 7%, or if you take 100% minus 7%, you end up with 93%. That's exactly what we ended up with as our base here. So since we're decreasing by 7% per year, we're going to multiply everything by 93%, which is 0.93. So you can kind of check yourself by looking for patterns like this. Make sure your numbers sort of seem to fit together. All right, for part C, we want to know what the expected value of the textbook is going to be in the year 2023. Well, we're not going to just plug 2023 in for T. That would be absurd. We're going to have to figure out how much time has passed. Our initial value, or basically our problem, started in 2019. And we want to look out to 2023. So that's 4 years later. So we're going to use the value T is 4. And if you plug that into your calculator, I'd like you guys all to try that. Make sure you're using your calculator properly. So type in 158, parentheses, 0.93, close parentheses, to the power of 4. Make sure you get the right answer when you type it in. Perfect. $118. So, and you can round that a little more or a little less. You could write 118.19 cents, whatever. Just try to get it close. Great job. So let's do number 4 as well. Number 4 is tricky, not because it's a hard problem, but because I wrote this in the worst way possible. Do you see the bottom where it says, if the population was about 321,400,000 in 2008, this should be up at the top. I should have put this up at the very beginning in the initial paragraph, because this is relevant to part B as well. So I didn't list it until part C, which is really silly of me. I just wrote these in the wrong order. So pretend like that phrase is up near the top, and that's going to help us with part B. All right, so we've got the population of the United States has been increasing at an average rate of 0.8% per year. Imagine that the population was about 321,400,000 in the year 2008. So is this an example of exponential growth or decay? Look for your keywords. Keywords like increasing. Increasing indicates growth behavior. And since we're dealing with growth, that helps us get started on part B. Part B says write an exponential function. And we know since this is growth that we're going to be starting with the function that has a 1 plus r in it. So all we have to do now is figure out what a and r are equal to. Well, a is our starting amount, or in this case, it would be our starting population. Our starting population in the year 2008 is huge. Okay, it's 321,400,000. Yikes. Okay, so lots of zeros in that one. And our 1 plus r will be 1 plus, ooh, this one's tricky. If we have 0.8% and we move this decimal 2 spaces to the left, we end up with 0.008. So it'll be 0.008 to the t. Be very careful with these decimal places when you're converting your rates into decimals, just because if you get that decimal place in the wrong spot, you'll end up with the wrong answer. All right, really quickly, let's actually simplify what's in those parentheses because we can, and maybe a multiple choice question might require us to do that, so we're just practicing. That'll give us 1.008 in the parentheses. And so for part C, we can kind of ignore the front because we moved that stuff. We're going to try to predict the population in the year 2020. So we're going to put a value in for t that represents the amount of time that has passed since 2008. So our problem started in 2008 and we want to calculate it in 2020. So the number of years that has passed is 12. So we're going to plug 12 in. This is like the sloppiest problem ever. So we're going to plug 12 in on our calculator. 321, 400, 000. A lot of zeros here. Make sure you count everything out right. When I plug it into my calculator, I end up with 353,648,000 and 856-ish. I rounded. In number 5, we've got a Chipotle restaurant making 650 grand every year, and their sales are increasing at a rate of 4%. So for part A, we're looking for a keyword. Anybody see the keyword? Increasing, which tells us this is a growth or a decay model. Perfect. Since this is growth, we're going to be using a y equals a times 1 plus r type formula. So let's find a and r. Anybody want to help me figure out what a is? That's our starting amount. $650,000. And then our R, or our rate, is 4%. But we have to convert that into a decimal, which will be 0.04. So if we were to simplify this a little bit, we would get y equals 650,000 times 1.04 to the t. That's our exponential expression. For part C, we're going to be plugging a value in for t, and they just hand it right to us. They say, figure out what the sales will be 7 years later. So we're going to plug in 7 to our calculator. 1.04 to the 7th power. And when I do that, I end up with 855,000. and like 356-ish. I rounded. It's okay if your answer's pretty close to mine, but you rounded slightly differently. That's not a big deal because these will be multiple choice. So you'll be able to find answers that are pretty close. All right. Any questions about number 5? I was walking around looking at your work and it looked like everybody was doing really well on number 5. So great job there. Number 6 is a bit different. We're still dealing with an increasing or a growth model. So you might think, well, let's start with y equals a times 1 plus r to the t. But when we go to look for our rate, we'll notice that there is no rate given to us in the problem. We are given a factor of increase. And factors we treat a little bit differently than rates. Factors replace this whole base. So this whole thing inside parentheses becomes 1.2. So we'll write this as y equals 2,500 times the quantity 1.2 to the t power. And that is our exponential function. For part C, it's just a matter of plugging 5 in for t and using our calculator to figure out what the solution is. So we're going to plug y equals 2500 parentheses 1.2 close parentheses to the power of 5 into a calculator. And when I do that, I end up with 6,221-ish. Any questions about number 6? Number 7, we're dealing with a print shop that purchases a new printer for $35,000. Must be a super fancy printer. Each year, the printer depreciates at a rate of 5%. Depreciates is one of the words that I mentioned yesterday. We defined it. It means decay. It's when something loses value. So for part A, we know we're dealing with a decay function, which helps us figure out for part B that we should have a 1 minus r in our exponential model. Now we need to figure out what a and r are equal to. So we get y equals our starting value, which is 35,000. And our rate they give us is 5%. Convert that to a decimal. So we'll have 1 minus 0.05. We move our decimal space 2 spots to the left. That'll give us 0.05. And just in case they simplify this on a multiple choice, we'll want to make sure we can simplify it too. When you take 1 minus 0.05, you get 0.95. And you can use a calculator on that. Part C is just asking us to plug in the number 8 for t. So into our calculators, we'll type 35,000 parentheses 0.95 close parentheses to the power of 8. And when I do that, I get 23,219.7. Okay, I'll do 220. We'll round it up a little bit. 23,220-ish. That's how much our printer will be worth after 8 years of depreciation. Now, the last problem, I think this one's really fun. The number of rabbits on Old MacDonald's farm is 40, and the population is doubling each year. So rabbits are well known for multiplying quickly. They are prolific breeders. So we should expect their population to increase pretty rapidly. This problem is suggesting that it's doubling. So there's a bit of a trick to this problem that we're going to talk about in part B. For part A, all we need to figure out is whether the population is growing or shrinking. Well, doubling indicates that it's growth, right? So we're going to be growing this rabbit population. So for part B, we're going to be looking at a model that uses a 1 plus r t to the t. The trick is figuring out what r is. Now, we have two different ways of doing this. Remember, we can either use a rate or we could use a factor. Then there are two different ways of thinking about this, and they're both the same. They'll get you the same answer, and it's just sort of a matter of how you like to think about these types of problems. So let's think about this in terms of a rate. If our population is doubling, that means we take our starting population, which is 40, and we add another 40 to it to double it, right? So we would take 40 plus 40 and we'd get 80, and that's how you double something. So what you're doing there is you're taking 100% plus 100%. 40 plus 40 is 100% plus 100%. So for our rate to double something, you take 100% plus 100%, which is the same as taking 1 plus 1. So essentially our doubling rate is you're adding in 100% each time. You take your starting value, you add in 100%, and that'll give you a 1 plus r of 1 plus 1. That's what you get if you think about this as a doubling rate. But let's think about it instead as a factor. To double something means to multiply it by 2. Right? So if we think about this as a factor, our factor would just be times 2. So if you're thinking about it as a factor, you would just use 2 as your base. And if you're thinking about it as a rate, you would use 1 plus 1 as your base, which is 2. Okay, so regardless of which way you approach this problem, you're either going to have 1 plus 1 as your base, or you're going to have 2 as your base, and you arrive at the same answer. So let's write out our exponential function. A is our starting amount, which is 40. And in parentheses, you can either use the 1 plus 1 to the t, or you can use 2 to the t. Either way, you're going to simplify it down to 2 to the t. So you can think of doubling something as multiplying by 2, or you can think of it as a rate where you're adding 100% each time. Either way, get the same answer. So that's why number 8 was a little tricky. We haven't done a problem like this yet where we have to come up with our own concept of the rate or the factor. It's usually given to us in some form. We had to kind of invent it here. But doubling problems aren't too bad. And part C should be easy. All we're doing now is we're taking our formula, which is 40 times 2 to the t, and we're plugging 6 in for t. So put that into your calculator. When I do that, I end up with 2,560. Holy moly. Look at that. We started out with 40 rabbits. And if we double that every year, in 6 years, we're going to have 2,560 rabbits. That is crazy. Exponential behavior can skyrocket really quickly.